today we are going to, so you have had a couple of very nice technical sessions now. And honestly, the speaker before me, he was articulating the importance of, joining or connecting dots. I have worked with Apple for a long time, and I have been a big fan of Mr. Steve Jobs. So I can tell you how important it is to connect those dots. So with that, I would again take a step back, completely into technology, and completely into a world where we are only dealing with data. What happens here? What you have seen, and this would definitely go on. So today we are talking about mastering the data engineering pipelines. Till now, until today, until you walked into the room, you have been processing data in a fashion where either there was an ETL, that is extraction, transformation, load, or an ELT, which is extraction, load, and transform. You knew about data warehousing. You know about data lakes now, but I want to take it one step further. What if there exists a world? What if data exists on your cloud service providers, whether it is AWS, Azure, GCP, or Ali Cloud, or any other entity that is sitting right on the bucket, and you would be able to analyze the data, read the data, process the data with any query engine? How would the story be? You do not need to. So I know the data engineering folks, I have been there in your shoes. I have spent a couple of, not couple, but many nights sleepless because the data doesn't match. The pipeline fails, and I get a Slack message, or I get a ping or something of that sort. And that is the life from where we are walking around, right? I'm not saying that that is something we are going to take away, but what I'm saying is we will have a different approach towards it, correct? So with that, this is what I meant to show you around. We have been talking about data lakes. We are talking about data warehouses. Just to take a step back, you all know about this, right? Data lakes, all kinds of data, structured, unstructured, all of it coming into the same space. You know about data warehouses, better models. You can build your analytics platforms right on top of it. And now we are talking about data lake houses and data lake analytics, where you are bringing in open structures, open table formats. In a couple of minutes, I'll show you, or I'm going to tell you what are these table formats and why open table formats. Already you must be aware of it. How many of you know about Hoodie as a table format, right? As soon as Cloudera came in, one of the first implementations which has happened, again, with a very large set of data. From there, we learned about Hadoop, how do we implement the same and then fine-tune it. From there, we walked a lot of our space. Oh, how do I do the ACID transactions? And I'll tell you today how we are going to build up the entire story, match them all up together so that we build a robust solution. So we came to the world of intersection with data lakehouse approach, right? So we are here having unified workloads. Very important is governance. Who, when, till what, right? Very, very important. Which data should someone see, and which is the data that should be hidden? Very important for PII thing. Interoperable storage is what we have been talking about. And then comes schema on read or write. OK, so this brings us, and this takes us to what are these table formats? What is the table format, first of all, and what is Apache Iceberg in the entire story of this data lake and lake house, and what is it that we are talking about here, right? So it's a way to organize your data sets, your files, right? And how do you do it? It looks like a single table. Even though your data, you must be aware of Oracle, you must be aware of those systems where you have got a table, you do a create table, and you write a statement, and your data remains on a particular tuple. From that day, that is one single row processing, we have walked a very long path towards getting columnar access of data, in-memory processing of data, SAP HANA, columnar processing of data, Vertica, Snowflake, and a lot of other providers who are actually processing your data faster, because we retrieve only columns, not the entire tuples in OLAP systems, that is online analytical processing systems. From there, we walk towards this architecture, where we are talking that there will be data sets, there will be files which are sitting in my buckets, and I would be looking at them like a table. It looks like a single table, but actually there are a lot of files which have been put together, right? It's not a new concept. That's why I asked you the question before, even before I started with this table format, and you know about it. We have been through the entire age of processing of data on these platforms, right? And this is all like Hadoop era, pre-Hadoop era also. This is something which has been existing. But then why the Iceberg format, right? Even though the systems existed and they were evidently used a lot, but there were a few downsides to it, right? The downsides, like there were smaller updates, like if you want to do only smaller changes to your data set, that was something which got costlier. No ways to change in multiple partitions, across multiple partitions. You could not build a snap because they did not have the possibility of having a single snapshot of data, and they only had one layer of metadata on top of it. It is something which is written out here. All the directory listings which were needed for running the table for large tables took a very long time. And of course, we also had this physical layout of table, and Hive table statistics were often stale. So when you have stale statistics, what it means is that what is lying in your data is actually not the one which is visible to you. So it's similar to stale bread and similar to your data not being accessed in the right path, in the right pattern, right? So from there, what we did was we brought in multiple metadata files on top of your own document systems, and that is the basic difference in thought. And this is something which has been started by some of the engineers and very great names there, like Ryan from Netflix. There are other contributors like Apple. There are contributors like, of course, Snowflake. And I must tell you, how does it make an impact, right? I'll tell you how many Google queries today run on top of Google in one day. It is around 4.6 billion. And if I tell you that it is the same number of queries on enterprise data which are running on top of Snowflake today per day, then this is the amount of queries that we process. And this is the scale that we are talking about, right? So just again, connect the two dots here. We are talking about real contributions from real world users of very massive scales of data. So it is bound to be more, this is an open project also, because I'm saying it is open table format. It means that the contributors are continuously giving their updates, and they are keeping the systems up, tight, and really awesome. How does it look like? Just one or two slides around the same. How does it look like? As I told you, the metadata or multiple metadata files. This is something in the making, coming up, and it will knock on your door very, very soon. So let's look at it. I do not have much information out here, like right, left, all of that. But what I wanted to tell you was, there are a couple. Let's start from down, which is from below. There are a lot of data files which are actually getting stored. It could be Parquet files. Again, it is a format, table format. It compresses the data. It keeps it much, much sorted. Just like you have heard any CSV format, or we used to have Excel sheet format. So Parquet is also a format of table. Okay? So you have got a data files. On top of it, you have a manifest file. What does it mean? Nothing but a list of what are the data files which are lying within me. So it is class monitor 1. Okay? So it will tell you, okay, these are the number of students. I am the monitor. I see that these are the data which is coming up together. Next, on top of it, on the right side, if you see on your screen, you would see a manifest list. What does it mean? it is like, let us say, school monitor, right? It tells you that this manifest list has got these many manifest files, which are again looking at the data files which are there in the list. This actually gives you a lot of flexibility, because you're not managing only one place metadata, but actually 2 layers of it. You now know, I'll tell you what are the advantages around the same in a couple of slides, but can't stop myself. But the manifest list will be able to tell you where the exact differences are being made and which are the levels that how many levels do I go down. On top of it comes the class teacher, the metadata files. I'm just trying to associate it with all of you so that we all remember this well. On top of it, we actually have the metadata files which are having the snapshots. The S0, S1 which you are looking at, they are the visible single table format which we are talking about, right? So you have got many data files. It will be very difficult for us to understand how do these files make a single table. I want to see it as a table. So these metadata binding up together, the manifest list together, makes a snapshot, and thus it tells you from here, when you look from the top, this guy, school principal who is sitting on the Iceberg catalog, when that guy starts looking at it, he sees that the teacher is standing, school leader is standing, monitor is standing, and all children are standing. So that is the view, and that is the concept of the data view that we are actually having here. So this is how the assembly of data happens on top of Iceberg, if I can put it that way. This is a prayer class, and this is how it looks from above the stage, right? So on top of it, on top of the metadata files, you got the snapshot, and you then got the Iceberg catalog. Right on top of it, here the game changes. Multiple catalogs can now process your file, can see your file, can see your table, can access your data. And that catalog could be any catalog which works on your data. So now, who becomes powerful? The catalog game, right? So this is a snapshot which I managed to pull out, where let us say you have got S3 and you have got, I have this problem, okay. I need water. So once you have this Iceberg table, so this is how it looks on your S3 bucket. So you must have already seen this, and all of you who work on AWS S3 know this. This is how your data looks like, your manifest file, your metadata file, your, the snapshot kind of a look. So this is how, so getting into the dirty job, right? This is how it would look like. And this is how your data is structured. So now what does it mean for you? What does it mean? Again, getting the value of the entire discussion, right? It means that you do not need to ingest your data anymore. Your data lies on your cloud bucket. Come on, man, bring your query engine, put it on top of it, bring AI, ML, MLOps, LLM, anything, and I'll be able to run it on top of it, okay? What is it not? It is not a storage engine. It is not an execution engine. It is just a view of the data, right? It is just table format, and it has got its own APIs, it has got its own libraries, and will be able to process the data. So that is the thing. Now I'll take one step further. You got the data, you need a query engine which has got the AI capacities, and that is where Snowflake comes into picture. This is a typical architecture, how Snowflake builds. The lowest layer is actually data, even before the LLM models and all of that come into picture. So we believe in, model garden approach. This is the only place where most probably you're going to see Anthropic, OpenAI, DeepSeek, all of them in one shot, including Meta. So once you have all of these models, you can build up specific functions. We have been talking about how AI is currently used to do the data engineering. So you can build those kinds of ML charts, and I'm going to show you how, maybe if my laptop connects and I can run it. And the next thing which you also see is that on top of it, you see something which is structured data. So if your data is on tables, that is Iceberg tables, or normal tables or external tables or any kind of tables that you have got the access to, you can build a chatbot and understand your data. Let us say you want to take it one step further. You want to process documents, .pdf files, .jpg files, .png files, and you also want to understand like chunk, vectorize, and then ask a question right on top of it. We have got something which is Cortex Search. You can build an entire RAG, which is a semantic and a lookup kind of a service. And Snowflake is also a vector DB. This is a large claim, but I'm making it here because we work very efficiently on the data which is currently getting vectorized. On top of it, you have heard a lot of the agentic AI, the agents and all of that. We have also built orchestrations on top of it. It can understand whether it should go for a structured data or an unstructured data and which tools do I need to review. Once we have done that, we can build our solutions, we can orchestrate, and we can build something with Cortex Analyst, and we can build an agentic system. Sorry. We have next slides also. So this brings us to the demo. I hope I can show that. How do I switch? Yeah, thank you. So this is a typical notebook on Snowflake, and I would like to run you through. This is how the Snow site looks like. What we are doing out here is we are accessing the Iceberg table, like I was just now showing. This is my Iceberg table. I have named it as demo, and within that I have built, it might take a little time for loading the objects, but let us come back to it. It has got all the product reviews, right? I am building a sales intelligent agent, and I'm today going to show you Snowflake, how does it make, it runs on 3 tenets, okay? One is making it easy. You have always seen very complex solutions. What if I tell you you can do this really quickly and it is easy? Second is efficiency. And third, very important, though ignored, is trust. You must have had sessions on responsible AI, trust, governance of data. All of it comes tied up in Cortex AI and Snowflake. So coming to the data set and coming to the Iceberg table kind of a format. So what happens is I'm just setting up an external volume to my Iceberg table. This is all that you do, right, on top of Snowflake. So this is the connection point which is between Snowflake and my AWS S3 bucket. Once I have done that, what I would do is I'm just creating an Iceberg table for the demo. I have already created one. What I would do is, once it has been successfully created, I would like to understand what is the data that is currently sitting in my table and what does it have in my product review. And I would like to first insert or ingest some data and see that this data moves into my AWS S3 bucket and is displayed to you. For today, because I was not sure if I would get the network or not, that is why I have run this statement. Pardon me, I usually run this along with you when I run the demo, but because of keeping a backup. But yeah, be with me. I have run this. I have done the ingestion. I've done the insert. After I have inserted and my files have been successfully created, I would go back and see. Okay, this is what I was actually expecting, but it's okay. I have a backup. The backup is here. How does it look like, right? Okay. So you would see the data, something in this fashion. So you would see that after you saw the demo, you would come to something of this sort, which would tell you that this is where your table exists and the product reviews exist, right? I just hidden my ARN completely, but you still saw it in one place. Once I've done that, and you have run your data, and your Iceberg table goes and sits on an AWS S3. Now what happens is that you are just getting a session. This is where the charm of Snowpark, running Python on top of Snowflake, comes into picture. And you are actually doing a complete schema setup. And this is a struct. There's a structure which is getting. So I'm just trying to show you here the different types of formats that can be processed right on top of Snowflake. Once we have done that, and I have got the data frame, and the data frame processing happens, I would have to run this. I would check, I would see I would play with fire. Let us see if it runs. Once a data frame has been processed, you would actually get the results out here. And you would also understand that once you have got, let us say, we can also do CI/CD, that is continuous integration with the data set which is sitting right on top of your AWS S3 bucket. It writes from Snowflake. Snowflake works as a query engine, yes, but it also can do the changes on the, on the block store that you have. So that is the entire pattern that we are trying to build out here. And on top of the data set that you have now ingested, processed, you can now see with the help of data frames, you can run something which is called as our Cortex LLM functions. What does it do? I am trying to find out what is the product name, what is the review, what was the sentiment associated with a review. You got a review, wow, your product is awesome. I loved the, the product, the chocolate which was sent to me. Someone else could say the chocolate was really bad because it was stale, something of that sort. You need to understand. So sentiment falls between -1 and +1. So -1 is really bad and +1 is really good. So that is the sentiment. So here, when you see the review sentiment and different numbers, it means that there is some product against which there are some positive, some neutral, and some negative sentiments which are coming up within the product review. Once you have done that, you would also like to understand what is the updates that you are currently, okay, connection is a problem. That's okay. What happens out here is that you can build, as I was mentioning, you understood your data better, you ran a LLM function which does the sentiment analysis, and then you are also creating a pipeline around the same. This is where I would call all the data engineers on you. This is where you would run a schedule, you would do a cron, understand how the data is getting processed and updated. Once you have done that, you can understand how your updates happen. And post the same, you can execute a specific task to do a continuous integration. And after that, you can actually run complex queries. The SQL review query, as you can see here. So you must be seeing in this notebook, there are 3 things that you can do. You can process on SQL, you can process on Python, you can use CPUs on Snowflake or GPUs on which we have got from NVIDIA on top of Snowflake, and you can do a distributed processing. Anything of that, that is fine. And after you have understood, that this is the sentiment distribution, these are the SQL, these are the reviews that we have obtained across months, across our products. Let us see how does it look in our, let us say, the graph, the bar chart, so that I can make more sense of the data. So this is how all of the story comes in and stitches in together when we are talking about what is the data which comes in. So I also had a demo screenshots. And let us say you would want to run the specific thing on top of Spark engines. Then I just hope it loads. Yeah. On Spark engines, you can also do this data frame kind of analysis from the same files which we have, and you can actually manage the data set, and you can process the similar kind of a sentiment analysis from Snowflake. So Snowflake is a very, very powerful query engine which does all of these activities, and that's it from me. I would love to take a few questions if you have any today.